Hello folks and welcome to Rational Zeros. Today we are going to be finding the rational zeros. You need your notes, a calculator, and a pen or a pencil, and we will get started. So, what is going to happen today when we are given a polynomial but we're not given a factor or a hint? Yesterday in our activity, when we did our activity, I gave you a hint. But now you don't have a hint. So what are we going to do? And no, you can't quit. Sorry. And no, we're not going to just say it can't be done. Okay, we're going to actually do it. But how do we do that? So our goal for today is to find a way to solve those polynomials that can't be factored and we're not given a hint. Okay? So we can't use one of the 5 methods that we've learned for factoring, and we aren't given a hint. What are we going to do? So we are going to become an educated guesser. We are going to guess. Guess and check. Guess and check. All right, but before we do some guessing, we're going to use the rational zero theorem. Now, the rational zero theorem is that every rational zero or solution has a form. So every polynomial has this rational zero form. Now, what does rational mean? Rational means I can write it as a fraction, and zero means a solution. And it has this form, P over Q. What? What's P over Q? I don't know what P over Q is. Do you know what P over Q is? Okay, well, it's not that hard. P, I'm going to tell you, is all the factors of the constant at the end of your polynomial. So when you have your polynomial in standard form, the number that doesn't have a variable at the end, if you factor it, that's your P. Okay? Your Q is all your factors of the leading coefficient. So when your polynomial is in standard form, you find your lead coefficient, that's at the beginning, and you factor it. Those are your P's over Q's. Now, what does this do for you? Well, instead of being a guesser of an infinite amount of numbers, because every number in the world, that would be infinity, instead of guessing out of an infinite number of numbers, I'm going to narrow my selection down by using P over Q. So I might only have 10 possibilities. Okay, so infinitely many possibilities or 10 is a lot easier number to work with. So that's what P over Q does for us. It helps us get a hint so that we can figure out how to finish the problem. Now, just to make sure we have the vocabulary correct, before I move on, there's 2 categories of numbers, real numbers and imaginary. Remember, imaginary is your I numbers. Your rational numbers are numbers that can be written as a fraction, and irrational numbers are numbers that can't be written as a fraction, like the square root of 2 or pi or the square root of 3. Okay, so what we're doing today is we're finding all those rational zeros, all the zeros that are possible that are in fraction form. All right, so let's find all the real zeros of this polynomial. Now, first of all, is the polynomial in standard form? Yes, it is. So what I want to do is I want to look at the factors of the end and the beginning. That's where I want to find my P over Q. Excuse me. So P is all your factors of your constant, the number at the end that doesn't have a variable. That's your P. Okay, now we want to find all the factors of 8. Okay, what are all the factors of 8? Well, 1 and 8, and 2 and 4. Those all multiply to make 8. Now, couldn't it be -1 and -8? Or couldn't it be +1 and +8? So really what I have are plus and minus factors. So I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now I have to find my Q. My Q comes from my leading coefficient. Well, this is my leading coefficient right here. That's a 2. Now all your factors of 2. So these are all your factors of 8. And then at the bottom you put all the factors of the leading coefficient, which is 2. The factors of 2 are 1 and 2, plus or minus, plus or minus. All right, now that you have that, we can now find a list of all possible rational zeros. Now, if we didn't compile this list, remember, there'd be infinitely many solutions out there. There'd be infinitely many that we would have to guess and check. But I'm going to compile my list, and it's going to get down to 8 or 10 or 12. And I can use that list. And from that list, I can become an educated guesser. So we got to compile our list. So to compile your list, you take every factor in the numerator and divide it by every factor in the denominator. So I'm going to take everything on top, and first I'm going to divide everything by 1. So 1 divided by 1 is 1, and it still can be plus or minus. 2 divided by 1 is plus or minus 2. 4 divided by 1 is plus or minus 4. 8 divided by 1 is plus or minus 8. And now you take everything on top again, but now you divide it by 2. So 1 divided by 2 is plus or minus 1/2. 2 divided by 2, that would give you 1. Oh, look there, it's already in my list, so I don't need to write it again. 4 divided by 2 is 2, already in my list. 8 divided by 2, that's 4, already in my list. So now I have compiled my list. These are the 12 possible. Now remember, this is possible. These aren't all going to work, but they're the possible solutions. Okay? So now what do I do with those possible solutions? Well, this is where I do what I did yesterday with the X factoring. I'm going to take those numbers, those possibles, and I am going to find one that gives me a remainder of 0. I'm looking for one that gives me a remainder of 0. So I'm just going to guess. Let's try -1. So we put -1 out in front. We're going to try -1, okay? And then we're going to synthetically divide and see if we get a remainder of a 0. We want a remainder of a 0. So 2x cubed, x squared, x, no x. So that's -5, -14, and 8. Bring down the 2. That's -2, -7. Well, that's 7. That's going to be 7, and 7 is -7. Oh, that's -7 there. +7, that's 15. Okay, that's not going to work. We're looking for a remainder of 0. Then we know it's a true factor. Okay, so that one didn't work. Yeah, let me see. Can I guess again? Let's try -2. Yep, this is where educated guesses, you're just going to guess until you find one that helps you. So bring down the 2, that's -4, -9, that's 18, that's 4, that's -8. Woohoo! I got a 0. That means this is one of my solutions. So if it is one of my solutions, the factor that it came from is x plus 2. So I could have told you to take this polynomial divided by x plus 2, and you would have figured out that that is a solution. So that's one of your factors. That's your solution. Now what do? We take our quotient, which is 2x squared minus 9x plus 4, and we factor it using one of our methods. In this case, I would use the AC method. So 2 times 4 is 8, 2 factors of 8 that give me negative 9, negative 8, and negative 1. Rewrite it as a 4-term problem. Make my squares. It'd be 2x, negative 1, x, and negative 4. So my other two factors are x minus 4 and 2x minus 1. That means my solutions, so those are my factors, and now my solutions are negative 2, 4, and 1/2. When I set each one of those equal to 0, I get my solutions. I should have 3 solutions because the fundamental theorem of algebra says if your degree is 3, you should have 3 solutions. Okay, so here we go. Let's try another one. Find all the zeros. All right. Well, first, we have to guess. No, we're not going to guess yet. What we're going to do is compile that list of P's over Q's. Remember, if we can find that possible list, there's one of them in there that'll help us get what we need. So my P is 9. Oops. My P is 9, and my Q is 2. And I want to factor all of 9, all the factors of 9, so plus or minus 1, plus or minus 3, plus or minus 9. All the factors of 2 would be plus or minus 1 and plus or minus 2. Now my list comes from taking all the factors on top and dividing them by all the factors on bottom. So I'm going to take 1, 3, and 9 and divide it by 1, and then I'm going to take 1, 3, and 9 and divide it by 2. So 1 divided by 1 is 1, plus or minus 1, plus or minus 3, plus or minus 9. Okay, now I'm going to take 1 and divide it by 2. That's plus or minus 1/2. 3 divided by 2 is plus or minus 3/2. And 9 divided by 2 would be plus or minus 9/2. And those are all the possible zeros. Okay, those are your possible zeros. Okay, now not every one of them is going to work. So we have to guess and check until we find that one that gives us a happy smiley face. All right, I tried negative 1 on the last one. I'm going to try negative 1 on this one. So I'm going to get my x cubed is the 2. My x squared is the negative 7. My x, I don't have an x, so that's a 0. And my no x is my 9. Bring down the 2. 2 times negative 1 is negative 2. And that's a 7. That'd be negative 9. That's a positive 9. 9. Negative 9. Oh my gosh, I got a 0 right away. That's awesome. All right, so we know that this is a solution. So we're going to write that over in our solutions. Negative 1 is a solution. What would be the factor that we get from that solution? Yep, x plus 1 would be the factor, because if I set that equal to 0, I'd get negative 1. And now we're going to factor 2x squared minus 9x plus 9. Okay, we're going to use the AC method again. 18, 2 factors of 18 that make negative 9 would be negative 6 and negative 3. Do your squares. 2x squared minus 6x minus 3x plus 9. 2x squared minus 6x minus 3x plus 9. That'd be 2x. That'd be negative 3. That'd be x. And that would be negative 3. And so my other two factors are x minus 3 and 2x minus 3. Therefore, my other two solutions, if I set that equal to 0, I'd get 3. If I set that equal to 0, I would get 3/2. So today is a lot about guessing and checking, but before you do any guessing and checking, if you compile that list of zeros, those possible zeros, P's over Q's, and just find one that gives you a 0 remainder, then you can finish out the problem. So you do have to kind of do a little bit of guessing and checking, but it's not so bad once you get all those, that list. That list is a lot smaller than infinitely many. All right, we'll see you tomorrow. Take care. Bye.